So, very good morning, dear students. Today we are going to discuss one of the important topic, that is the nucleophilic addition reaction. So, yesterday we had discussed about how the carbonyl group of the aldehydes and ketones, it undergoes the nucleophilic addition instead of electrophilic addition reaction. तो nucleophilic addition reaction जो होती है, it is because of the structure of this carbonyl group that nucleophile attacks on this carbonyl group, as a result of which there is a formation of addition products are formed here. So let's see one by one different nucleophilic addition reactions. For example, here we are taking the aldehydes and ketones. Actually, when we treat with this different types of reagents, for example, hydrogen cyanide, sodium bisulfite, or Grignard's reagent. When we treat these aldehydes or ketones with hydrogen cyanide, sodium bisulfite, or Grignard's reagent, then you will see here that the addition products are formed here. So let's go one by one to how the reaction takes place. Addition of hydrogen cyanide. So this reagent, when added to this ketone, the formation of cyanohydrin takes place. It is not it is any of the carbonyl group of the aldehydes or ketones. So here the formation of cyanohydrin takes place. The product formed is addition product of cyanohydrin. Cyanohydrin, why it is called as cyanohydrin? Because there is a one cyanide and hydroxyl group present in this carbon atom. That's why it is called as a cyanohydrin. One of the important synthetic reagents जो होते हैं cyanohydrin, को further हम देंगे how the from the cyanohydrin alpha hydroxy acids and alpha amino acids can be prepared. ठीक है. So first of all, here we will take the one of the example. Here is the acetaldehyde, one of the group of the aldehyde group are taken into consideration. When we take this acetaldehyde group and when we trade with this hydrogen cyanide, the product here formed is acetaldehyde cyanohydrin. Clear? Similarly, we will take another example. No, this was aldehyde and this is here ketonic group, and when treated with this hydrogen cyanide reagent, and here the additional product form a cyanohydrin that's called as acetone cyanohydrin. Clear? Similarly, now we will see the mechanism of the reaction. You must know that hydrogen cyanide, actually it is a highly toxic substance and is a very volatile substance. So while doing this reaction, you must take precautions in order to prevent yourself from health hazards. Clear? So here let's see how the mechanism of the reaction takes place and how this nucleophile is generated during the reaction. So hydrogen cyanide, it is actually the base. Hydrogen cyanide is treated with the base. For example, any of the base, you will take the sodium hydroxide under consideration. And from sodium hydroxide, you will see that the sodium hydroxide will give sodium positive and OH negative, and ionization of the sodium hydroxide gives hydroxyl ion, and this hydroxyl ions, when this hydroxyl ion will combines with this hydrogen from the hydrogen cyanide, and it forms the water here, and is the formation of here cyanide having negative charge on it, and it's a electron rich species, as a result of which you know that any of the chemical species having electron rich centers, this will act as a this will act as a nucleophile. Clear? So cyanide actually here acts as a nucleophile means nucleus loving. So it will attack at that carbon atom where there is a deficiency of the electrons. So here we will see the nucleophile is acting. It is acting as a it is cyanide ion is acting as a nucleophile, and it attacks as the carbon center of this carbonyl group, because we had discussed already that carbonyl group actually it is having the slightly del positive charge and del negative charge, and the cyanide group being electron rich center will attack at the carbon which is electron deficient, where there is electron deficient center, as a result of which you will see that some intermediate product is formed here. So let's see This is a intermediate product formed where cyanide and there is a shifting of the actually when the nucleophile approaches to this electron deficient center carbon, there occurs the shifting of the electrons from this double bond to that of this oxygen, as a result of which this intermediate product formed here further under addition of water in it. So as a result of which hydrogen from water, it gets proton from here. So H2 will combine with this oxygen, as a result of which hydroxyl OH ion will be formed. OH will be formed, as a result of which cyanohydrin is formed here, and from here water remaining is hydroxyl OH negative ion from this water. Clear? So here it is a mechanism of the reaction, how the cyanide ion being a nucleophile attack this electron deficient center, as this is called as a nucleophilic addition reaction, because the nucleophile cyanide is attacking this electron deficient center, and here the formation of intermediate is formed, which further under presence of water gives cyanohydrin. Clear? So accordingly we will see, according to acetone cyanohydrin is formed or acetaldehyde cyanohydrin is formed. It depends upon the whether you are treating as you are treating acetones, or whether you are treating aldehydes or ketones under the reaction conditions. Okay, clear? but but we know that cyanohydrins prepared during the reaction, these are very much important, useful for the synthetic reagents. As already mentioned, these are used as a synthetic reagents for the synthesis of alpha hydroxy acids and alpha amino acids. This is called as a Stricker synthesis. Stricker synthesis, this is one of the syntheses where we are synthesizing the alpha hydroxy acids and alpha amino acids. So here we will see that how the alpha hydroxy acids is prepared. So this cyanohydrin, you will see the cyanohydrin here, it is present in presence of water or in presence of acid. It gives alpha hydroxy proponic acid. That's what is called as a lactic acid. So here is formation of the actually this cyanide group. Here in presence of cyanide group, you will find here the carboxylic group. The carboxylic group gets added. It is having different mechanism, but here there is no need of to discuss the mechanism of this synthesis, alpha hydroxy acid synthesis. So you will see this application of this cyanohydrin is that from the cyanohydrin it is acting as a synthetic useful synthetic reagent, where we are preparing the alpha hydroxy acids and alpha amino acids by, this is called as a trigger synthesis. Clear? You Let us see second reaction we will take, where this is how alpha hydroxy propanic acid, that's called a lactic acid, is formed. Similarly, from the cyanohydrin we can prepare the alpha amino acids. Here let us see here how they are prepared. Let us see, take the example of the cyanohydrin. It is cyanohydrin. This is cyanohydrin. Actually this is not working properly, sorry for that. Cyanohydrin CH3, here it is hydrogen here, and in presence of ammonia, here you will see that the in presence of ammonia, that hydrogen, one of the hydrogen will get abstracted to this hydroxyl ion as the formation of water, and there is a formation of the intermediate product. You will see here the intermediate product will be having one of the NH2 group gets attached to there, and here the same condition CH3, and it is hydrogen, and this is cyanide ion. This is will be here hydrogen, and this is will be here CH3. Clear? And further this intermediate reagent in presence of water or in presence of any acid, so it will be converted into that. We will see, if I will write here that the intermediate formed during the reaction, you must follow the steps properly and write down this on your notebook. there is here hydrogen intermediate, and this further in presence of acid. Clear? So here you will see that formation of alpha amino propanic acid is formed. There is amino NH2 group, it gets added here. Hence in presence of instead of cyanide you will get here carboxylic group, and here it is CH3 methyl group, and here is hydrogen. This is called as alpha amino, write down alpha amino propanic acid. Clear? Or it is also called as uh, it's also called as alanine. So one of the amino acid that's called an alanine, which is prepared from the cyanohydrin. So cyanohydrin is having the very useful, important. It is very useful synthetic reagent for the preparation of the hydroxy acids or lactic acids, or any of the amino acid is prepared from this cyanohydrin. Clear? So this was one of the application of cyanohydrin. Second addition reaction, though, let us see the second addition reaction of sodium bisulfite. Addition reaction of sodium bisulfite, NaHSO3. Here, but you must remember here that the carbonyl group here, the carbonyl group may have any of the alkyl group here attached here, or it may be have any of the alkyl group or any of the hydrogen group. But you must here, in case of addition of sodium bisulfite, only those aldehydes or ketones undergo the addition reaction with sodium bisulfite, which is having less hindered site, which is having less hindered at carbon site, or we may say that which is having small, which does not having the bulky groups, that the R group should not be very bulky. That's why the reaction does not takes place. So it is necessary condition that less hindered aldehydes and ketones reacts with saturated solution of sodium bisulfite to form addition compound. So the compound must be less hindered, as so that the nucleophile easily approach to this carbon. You let us see here that if we take any of the alkyl group, for example, if we take some of the bulky group here, for example, this is some of the, sorry. So if, for example, is a bulky group here attached here, though two bulky R groups are here, or maybe in any of the butyl, pentyl, isobutyl, or any of the group is here. For example, it is the isobutyl group here, and when we see that when the nucleophile is approaching here from the back side of the reaction, it will get some repulsion, steric hindrance for this approaching of the nucleophile, as a result of which nucleophilic attack will not be feasible. It will be hindered. It will experience some repulsion from these bulky group. So this group must not be much bulky. It should be as small as possible. Okay. So let us see here. We will take the how the cyanohydrins are formed when this aldehydes or ketones are treated. Sorry, cyanohydrins nahi, actually sodium bisulfite compounds and additional compounds are formed when the ketones or aldehydes are treated with sodium hydrogen sulfate, or we may tell it sodium bisulfite. So here we will see how the reaction approaches, how the reaction is proceeds. So it is a carbonyl group, any of the aldehyde or ketone group. When treated with this sodium bisulfite, it forms the addition product that's called as a sodium bisulfite compound. Sodium bisulfite compound. Clear? Let us see. Take the example here. If you are taking the aldehydes under consideration, treating with sodium bisulfite, the product formed will be acetaldehyde sodium bisulfite. उसमें in case of the cyanohydrin, we will see that acetaldehyde cyanohydrin addition product was formed, but here this is acetaldehyde sodium bisulfite is formed here in case of aldehydes. Clear? Similarly, in case of ketones, you will see that when treated with sodium bisulfite, you will see here the formation of acetone. Sodium bisulfite is for here takes place. So acetone sodium bisulfite is formed here. So the reaction approach mechanism of the reaction is similar to that of the we had discussed above, but here the nucleophile is different. Here the nucleophile is actually the sulfate SO3H ion. So being electron rich species, this will approach towards carbon atom, and though as a result of this nucleophile will approach this carbon atom to this attack this carbon atom, which is electron deficient center. So this nucleophile being electron rich will attack to this carbon being electron deficient center, as a result of which you will find here that the intermediates formed. But here what takes there occurs the hydrogen shift is takes hydrogen shift. This hydrogen in SO3 as sulfide in with the hydrogen which is connected with this sulfide, will get shifted from there to this oxygen negative ion, as which further results in the formation of additional product in presence of sodium. So SO3 negative ion will abstract one of the sodium atom from the reaction mixture, as a result of which the product will be formed like this. Okay, so let us say take the examples of the he will we have taken this actually the mechanism of the reaction. You will see here, if this the product will be, it depends upon the whether you are taking here the aldehydes or ketones. If there will be ketones, then the product will be formed as acetaldehyde sodium bisulfite. If this will be the ketone, here the product will here be formed as acetone sodium bisulfite. Clear? So this is second reaction, the second addition, nucleophilic addition reaction, in which the nucleophile, here the nucleophile is somehow different. It is SO3 negative H. So being electron rich center, this attacks at this carbon atom, as a result of which you will find the additional product is formed. So let us take the another reaction. This addition reaction of Grignard's reagent. Here the addition of RMGX takes place. Different alcohols can be prepared based on nature of the Grignard's reagent and the carbonyl compound. So here you must see here that from this addition reaction of Grignard's reagent, by the addition of this Grignard's reagent, different alcohols can be formed. Primary alcohol may be formed, secondary alcohol may be formed, tertiary alcohol may be formed. It depends upon the nature of this carbonyl group. What is the nature of the carbonyl group, and what is the nature of this Grignard's reagent? Grignard's reagent, you must we know that there are different the formula of the Grignard's is RMGX, but or may be different. It may be methyl, ethyl, propyl, butyl, any of the value of the R you may take. You may take, as a result of which you will find there the formation of different types of alcohols will be formed. It may be primary, secondary, or tertiary. Let us see here one by one what is actually forming here. One second. So from this addition reaction, by when we treat this aldehydes or ketones with this Grignard's reagent, that is RMGX, you will see the formation of alcohols takes place. The nature of the alcohol will be depend upon the nature of the carbonyl group, that is aldehyde or ketone you used, or nature of the Grignard's reagent you are using. Clear? So it depends upon these two, what will be the nature of the product formed in the reaction. So let's see, take the example here. It is a formaldehyde. It is a formaldehyde. Actually here are hydrogens here. You may see actually it's a formaldehyde. Formaldehyde having the formula like this. This is H here, this is H here. So this reaction is actually the formaldehyde here. It is when treated with this RMGX. Clear? So this actually CH3 magnesium iodide. Clear? The reagent is here CH3MgI, and you will know that this Mg, and this will and this will attack here, as a result of which you will find the formation of OMG is formed here, and CH3 is attached to this site. The mechanism of the reaction is somehow different, but something different, but we are not here to discuss that mechanism, but you just remember the how the different types of alcohols are here formed by taking a different aldehydes or ketones under concentration. So here the product formed will intermediate product is here when the formaldehyde is treated with this Grignard's reagent in presence of acid, and the product will be formed here. It is a primary alcohol here. The primary alcohol is formed here. Clear? So and the side product will be formed. The main product here formed is the primary alcohol. Clearly, the second. So it depends upon this. If we now take the second, we take acid aldehyde as a for second compound when treating with this reagent CH3MgI, the intermediate product second will be formed, which under and in presence of acid will give us secondary alcohol. So in case of formaldehyde, primary alcohol is formed. In case of acetaldehyde, the secondary alcohol is prepared, formed. And in case of ketone, you will see here the formation of tertiary alcohol takes place. Clear? So mechanism we will discuss further mechanism of the reaction. So from this reaction, from the addition by the addition of Grignard's reagent to this carbonyl group, whether aldehydes, ketones, or whether aldehydes or ketones, it depends upon the nature of the ketone group, carbonyl group, or nature of the reagent, that is Grignard's reagent, and accordingly the alcohol will found, maybe primary alcohol, maybe secondary alcohol, maybe tertiary alcohol. When we use this formaldehyde, we'll see here that primary alcohol formation takes place. Similarly, when we take consideration of the acetaldehyde, to secondary alcohol is formed here. Similarly, if we take the ketone under consideration, reaction with ketone, so you will see here that the formation of tertiary alcohol is takes place. Clear? The mechanism of the reaction is like that. You will see actual mechanism of the how the reaction approaches. So here what happens here, that this is carbonyl group, carbon being electropositive center and oxygen being electronegative center, as a result of which you know that from the RMGX, or it may ionize like this, R positive plus MgX, when it occurs simultaneously. So it gets some positive charge here. When it gets some positive charge, as a result of which this sorry this sorry this actually this does not takes this does not gets positive charge. Actually it gets negative charge here, and MgX being negative, being positive charge. Clear? As a result of which this R group will approach toward this carbon. So here the R, this center acts as a nucleophilic center, and this approaches to this carbon, and MgX will combine this, it forms the MgX. So the reaction intermediate formed is here, and further hydrolysis it gives alcohol plus MgXOH. Clear? So this is how the reaction takes place. Although the reaction mechanism is somehow different, but you only remember here that it depends upon the nature of the aldehyde or ketone you are taking. Accordingly, the product will be primary alcohol, secondary alcohol, tertiary alcohol. When we take the consideration of formaldehyde, you will see formation of primary alcohol takes place. When we take the consideration of second, and that's called the acetaldehyde, you will be secondary alcohol is formed, and in case of ketone, you will see the product formed will be the tertiary alcohol. Clear? So this was all about today's topic. Hope you understand.